Our next speaker this morning is James Peake. When I called Jim and asked him if he was willing to come and speak to us at the Restoring the West conference, he said something like, "Are you sure you want me to? I'm going to make a lot of people mad." He said, "Yeah, you're the guy I'm looking for. Different point of view." So Jim promised me he would stir it up a little bit. I'll be disappointed if he doesn't. Jim Peake retired in 1999 from the Department of Fish and Wildlife Resources at the University of Idaho. His research interests centered on ungulates and their habitats, with first publications in 1962, and I was almost born then, and continuing until today. He is currently working on a review of large predator management in North America for the Wildlife Society, an analysis of a 20-year record of plant production and mineral content from shrub steppe in central Idaho, and a history of the LOCHSA elk herd. He does not plan to retire fully until dementia becomes so severe he can't remember what he was supposed to be doing with these efforts, which in retrospect may not be far off.
Thank you, Darren. Darren actually took quite a chance on inviting somebody like me in here. I had to ensure him that my memory was still intact and everything, and I could probably handle a talk, but what I didn't tell him is that my memory is pretty good for the years 1950 through about 1970, and then from there until about 5 minutes ago there gets to be some gaps. And then you hear something about the whole, especially us ecologists, we hear something about the whole being more than the sum of the parts. Well, in my case, each part is worth quite a bit more than the whole. And for instance, I just had 4 teeth removed and replaced by 3, and that was $10,000. And I figure each part, if you were to add them all up, I'd probably be worth billions. But the whole, well, I'm worth more one part at a time than I am as a whole animal, I'll tell you that much. But enough of the military-industrial complex healthcare issue. What I'm here to talk about is hopefully a rehash for a lot of folks, entertainment, and maybe it aggravates you a little bit too before it's all done. Somebody said a while back that any research that had been done before 1990 was suspect and the statistics were questionable and the rest. So what I propose to do is take you back before 1990, if I can get this thing going. These are my introductory comments. First of all, I'm going to make an argument that we probably, over the last century, experienced populations of deer and elk that we're probably unlikely to experience again for a number of reasons. And I've got a couple of case histories to make the case. One of the case histories shows how much uncertainty there is when you start dealing in this kind of stuff. And then some cases may have to do something with livestock, such as what we see here, namely the cow. Just to back up a little bit, if you read Mann's article on 1491 and you start looking at some of the research, a fellow named Ripple's tied into one of them here, as you can see. Why, you realize that original America was pretty well occupied by humanity. And all this stuff about wilderness being untrammeled and whatnot, is the evidence comes around why you begin to realize that there were a lot of people. Man spends a lot of time in worrying about the Central American Mayan culture and the Incas and whatnot, but he addresses the numbers of post-Columbian occupants, and especially densities were very high in the Mississippi River Delta, the southeast, along the coast, the salmon eaters up in the Pacific Northwest. You had the Anasazi in this country and south. These were very highly evolved societies. And the thing I take away from this was, you know, these people came into this country, you know, right at the tail end of the Pleistocene as the glaciers were receding and whatnot. And they spent somewhere close to 10,000 years before they acquired the horse and had contact and all the diseases and wars and everything that subsequently resulted when they contacted Europeans. Well, I don't know what sustainable societies are these days, but in those days where you have societies that have been sustained over long, you know, thousands of years, it makes you wonder, you know, we've been around here for a couple, 300 years. Do you think our society is sustainable in comparison? I don't know. Thing with Bill and his colleagues and Paul Martin. Paul was one of the major players in the tree ring group down at the University of Arizona. Developed the Pleistocene overkill hypothesis that's been subject to great arguments ever since. But he argued that Aboriginals were able to extirpate the megafauna. And there's been subsequent work on that, of course, that argues against it, but it's up for grabs. But anyway, these folks took a look at the Lewis and Clark expedition, and where did they actually see a lot of wildlife? Those big buffalo and elk herds. And central Montana, the muzzle shell country, was one. Well, the point was made that those are areas where the Blackfeet and the Crow were at each other's throats, and it was a no man's land, a no person's land in central Montana. And the argument, the implication of that is that these tribesmen were having effects on the big game, and when they were absent, why then ungulates could increase. What I derive from a lot of this is that, one, you know, our view of having to exclude contemporary humanity from make our presence minimal is up for discussion. It's how our presence should be done and should be accomplished both in parks and wilderness areas and the multiple use areas too, and that wherever you go there's evidence that humanity was there right along with the wildlife resource and the plants. And I think that's a major argument that these folks make that we need to readdress. And this business of an area being untrammeled by man is probably only in our minds and is a fairly obsolete issue. Let's go back to the same thing that Terry started with and Bill started with. A fellow named Graham Cawley he's an Australian ecologist. He got to looking at the Himalayan tar, and this was a publication came out in Ecology in 1970, and he took a look at what he could learn about eruptions from the old Kaibab deer incident that everybody should probably heard ad nauseum. But he made some points that the eruption causes, he concluded they weren't readily identifiable. You couldn't single out one cause, primarily because the predators had already been taken out and heavy livestock grazing had occurred and lack of hunting was involved. So he looked at the Himalayan tar. These are a goat-like animal with short horns that were introduced into New Zealand an island, as you're well aware, that didn't have any native ungulates in it. And he predicted that there would be an eruptive sequence, as we've seen and heard about before. Then there'd be the collapse. Then you'd have some kind of a stable equilibrium. And the thing I take due note with my background and interest is that the vegetation complex would change. And the original New Zealand tussock grassland, which would be our bunch grass, was a big Chianocloa species. And basically these tar took the Chianocloa out. He had big transects that ran across large chunks of country, and what it was replaced with was a bluegrass. It introduced bluegrass to boot, and it was directly attributable to the tar grazing. Well, he made some comments that subsequent research, some predictions that subsequent research has played out. The initial tar population should be highly productive. Population at the highest levels, stage 3 here, would be old age, less vigorous. You'd lose the productivity. The decline, you'd lose the productivity and the survival. And then the equilibrium, you'd show increases in survival, production, vigor. And this kind of stuff, I mean, it's been identified with in populations across with virtually all native species anymore. So these old predictions are certainly part and parcel of the situation. Well, here's what's happened with mule deer across the western U.S. I look at harvests primarily because I don't trust population estimates on these things. Harvest data is pretty consistent, and these are the unregulated buck harvest. In other words, what a wildlife agency does is they set a season. You can take any buck, and then it so the number of bucks out there probably reflects probably reflects the population. And as you can see, you can you can log this stuff, and you can get a pretty good correlation. I don't have the correlation on here, but it's generally, you can see the fluctuations here. We'll talk about that, but across these states, these are the states that have had these kinds of seasons that probably reflect population trend. And as was talked about yesterday, you can see that there's been a change, a decline. It includes Oregon, Wyoming, and a number of the states around here. Well, let's take a look at one study area. This is one example of what's happening in the West. We had a chance to take a look at the Devil's Garden. This interstate deer herd has been studied in Oregon and adjacent California since 1929. And the Oregon folks, they'd ride horses and look at the animals. They'd count them off a horseback. They'd count them off. They'd look across the sand roads. They'd do it from the air. The data sets are variable, granted across a long time, but they probably do reflect what's going on. I might point out that recent information that corroborates what I'm going to show has been done independently by folks down in California too. So it's a pretty well-known mule deer herd here. The Wainema National Forest here, pretty close to Lakeview and Klamath Falls down here. Our study area was one of basically the Sprague unit of that national forest. It's dry country, and here's the evidence, landscape level evidence of that one Wainema study area that we're looking at here. The blue in 1953 is treeless shrub steppe, the shrubs being big sage species and their associated species, the rabbit bushes and whatnot. And you can see what happens about 35 years later. I mean, there's just not much blue left. It's PJ and pinyon juniper and ponderosa pine. Higher elevations you get into white fir and whatnot. So there's over a 35-year period here. There has been significant reforestation of a major part of that national forest. And this is just one more example of many on the western national forest that show this kind of reforestation. The point I want to make is this happens pretty fast. And when you look at the stand prognosis models about tree growth, if you're dealing with a more mesic species like white fir with a high side index of 110, these side indices, the higher they are, the faster the trees grow, basically. Down to the lowest index, and look at the pea pine index of 140 or half of that, slow growing drier sites. Notice that the canopy closure that affects the understory, it has this same kind of trend using these predictive models that have been developed. Forest Service research, incidentally. And along in about 50 to 70 years, you basically wind up with a 70% canopy closure. So once the trees are established, why that 35-year period that I was talking about with that GIS data, why you can see that these, the infill is pretty fast. We all realize that this is fire related, or the absence of fire, I should say. There had been Don Jameson back in '67, did the correlations. This is herbage biomass in understories on this curve here, and this is canopy closure on the overstories. And notice how rapidly canopies go from when you start getting canopies upwards in the 20% range. Notice how steep that curve is on that. So you can lose the understories, that's deer food and whatnot, pretty dang fast. And of course, you can use these models to project things, which we'll show you. And Don suggested this is a general model for overstory relationships in his concluding remarks, but you'd have to test that out. We actually did down there in that Southern Oregon situation, and concluded that he was pretty close to being right on. Well, I don't expect you to see all this, but you can take that long-term deer population data set and run it against April precip, monthly April precip, June precip, August precip, October and December, and add in canopy closure and time, and you can get a snazzy estimate of the change in numbers from time t to time t plus 1. And here's how close you can predict this thing. The solid circles are the ones that are observed. That's the actual trend on the deer population. Look how close we're predicting this. I had a biologist tell me one time, field biologist, say, well, I still think there's a need for field biology. I think what this shows is how seriously the need for field biology really is, but what we could do to further our understanding of what's going on. My argument here is, okay, how come this doesn't fit so well with the trend? What actually happened there? What happened here? And the rest of this is pretty predictable, but how does this work? And when your observations don't fit the model, then is when you want to go back out there and find out what actually went on. And it's going to happen over the discourse of this a conference we heard a lot of talk about uncertainty and whatnot, and I certainly subscribe to that. And this may look good to predict hindsight, but when you start using it to predict the front, you're going to see a change inevitable. Then let's find out. That's when we start to learn. And it takes field work to do that. Okay, well, this is in the middle fork of the salmon, a different kind of a scene. This is shrub steppe for most of the time. And this is a photograph taken incidentally by Chuck Peterson, who's a herpetologist from Idaho State University. It turns out there's a rattlesnake hibernaculum on that little knob right there. And Chuck went out and marked some of these crazy things, and then he found a student who was dumb enough to run up and down these hills. And they had snakes running all over these passes and around. I mean, these rattlesnakes move, and it just tells you something about how little we really know about a system. This drainage here is about 35 miles from the nearest road. It drains east into the middle fork, which I think is down in there. And those are the Bighorn Craigs, which I used to take people up on this slope and tell them they were privileged to see the west side of the Bighorn Craigs, and probably less than 50 other people would see it for that year. So this is pretty deep backcountry. We're going to go through the same old story again, but the Forest Service back in the late 40s and early 50s put in a bunch of exclosures. And these exclosures, you can see the outline of one of them here. This is up in one of the big drainages, or one of the more open areas along the middle fork of the salmon. This is all inside the Frank Church River No Return Wilderness. And the reason they did that is they had a mule deer population in there that was browsing everything up, and both Idaho Fish and Game and Forest Service were very concerned about that. And so these exclosures were set up with the express purpose of showing people what the deer damage was happening in here. Well, you know, I maintain that back in the 1940s we were coming out of the Second World War. No predators in there, no hunters. They could have probably had a market hunt in there, and it wouldn't have done any damage to the deer herd. I mean, it's just too far in, and nobody was going to go there to do any management on mule deer does of all things. Why heavens! So my wife and I went back in there. We spent a year in the, took a sabbatical, and we spent a year in the wilderness. And one of the things we did was fuss around with these exposures. Now, the Forest Service, I better get to going. Taking the fences out because it's wilderness. But here's one of these exposures looking inside it. There's a lot of bitter brush in there still and sage, but when you looked outside, a lot of it was gone. And the conclusion we drew from this is what they had done has protected a whole lot of stuff that, as time went on, became senescent and decadent and whatnot inside these enclosures, whereas the browsing outside had really reduced it. But how did all that browse get there in the first place? Well, there was one record where one of those openings, they wintered 1,300 head of pack stock in those basins. They were supplying the Thunder Mountain mines, and that pack stock was not being fed. So they had what Leopold called the old storage effect, and of course that enabled the deer population to increase. So our conclusion is what we're looking at now with a mix of bitter brush and whatnot is very different than what occurred through the last century, and is pretty close to an approximation which occurred to there prior to 1900. Okay, here's some hunting units. These are all inside the frank, except for some of the Unit 28 here. We've had a little fire in that country over the last few years, and here's the GIS estimate on two of those units. And what we see in that basin, there's about 2 million acres in that whole country. And when you look at since 1980, about 57% of it's burned. This is all wildfire. That Big Creek drainage I showed to initiate this segment of the talk, that was 240,000 acres that went out in the year 2000. Now, if that isn't restoring the West, I don't know what is. Well, how did the elk and the wheatgrasses respond? We had data sets. Since this was done before 1990, well, you can discount those 2 years, but you can see over the 1990s here, we had some pretty good precip years. This is highly productive, or is highly predictive with April through June precip. So we had good springs, and so we had a lot of wheatgrass production. Then we had the year following the 2000 fire, which took out all my plots, and the wheatgrass production was suppressed a little bit. The next year, a better year. The next year, we've had drought years more so since then. But anyway, that's a 20-year record, and what I'm using it for, any 1 year doesn't mean much, but when you get 20 years, then you can start trying to use it for predictions. And this is an elk winter range here. 3,500 head elk will winter right in here. It's about 16 miles from the Taylor Ranch, so it's a walk up there for these lost souls that were helping me. And what we would do is going to clip this range every year, and it's a beautiful wheatgrass stand. There's no evidence the elk are hurting it at all, and they graze on it all winter. But it was pretty easy to clip, and after a while, it dawned on me the reason it was easy to clip is because there was no last year's growth left. I mean, they took it all off basically. But then the fire came in, and then you don't see it too well. But after the fire, this was all forested over on the other side, and that was taken out. Well, now we'd expect with the 240,000 acre fire that took the winter ranges and the summer ranges and everything else that the elk herd would respond. Well, it didn't really. You can see here, here's 2,000. The elk herd actually may have gone down some and then back up. These counts, how reliable they are, I don't know, but you can see that the hunter harvest never really changed much. You can't say that those elk respond as much. And then I don't know how much habitat you have to do before you improve it, but when you burn the whole drainage, why, you'd expect a response. On the other hand, we saw major deer increases. Again, I don't believe there's no population data, but the hunter harvest went up. We actually saw one mule deer doe with 3 fawns one time. Totally unexpected. Here's the changes in the LOCHSA. We've seen elk in that country. There were elk way back, been seen in the middens. And then after the 1934-33 burns, Pete King fire, that elk herd went up in eruptive sequence, and then through a series of tough winters and whatnot, it's continued to collapse. Changes. Notice the shrub sapling changes and the shrub. Of course, those elk are foraging on the shrubs, and in 1972, the estimates were 24,000 acres of shrubs, went down to 14,000. But look at what happened. Shrub sapling stuff, and even age timber changed, and then the mature forest. Major changes in the forest over that period. Here's what it looked like in 1936. This is a picture that the Washington Air National Guard took. And they must have been on a training mission, so I presume they got past the Yak and Flack on the Washington-Idaho border and were able to sneak in here and photograph this part of the LOCHSA. You'll notice that in 1936 there was no river, there was no road on the river. And you notice this is what we call escape cover. That's what's left of the forest. I mean, this is shrub field and cliffs down in here. Well, this is the same area in 2010. I went up there with a forest economist. I've always had a problem with forest economists, but I was able to overcome that since he was a friend and he also had a plan. So we photographed it again, and these are cliffs, but there's been a change in the elk herd up there, and it may have something to do with the forage phase. Okay. Yeah, just to talk about Maine, Aroostook County, the same things going on in parts of the east. We've had a deer harvest up there over a long period of time, but now it's changed, and I think probably because of forest change rather than coyotes, but everybody blames the coyotes. Well, what I'm concluding here is that a lot of major change in attributable to plant succession in forests and changes in grazing patterns in steppe. We're not going to, I mean, livestock's so much better managed these days than it was. We're not seeing these major changes. So it alters conditions. And we're probably not going to see these levels we saw in the later part of the 20th century again. And in prehistoric times. I think a lot of the contemporary arguments about forest health and biodiversity is also going to retrend. I think, unfortunately, there's a tendency for us wildlife types to focus on short-term issues, which we have to do, of course, but the consequences of these long-term changes have to be looked at, and climate changes that affects habitat, who knows? And so we have one final comment. I'd like to give a full credit to the blue bunch wheatgrass, formerly known as Agropyron spicata. Us old-timers used to call it ag spic. Now it's Pseudoregnaria spicata, and I just call it pissed. Would there be a question?
Jim, I wonder if you could clarify, you made a comment a couple of times about the populations of deer and elk will never be again what they were in the 20th century. I wonder if you could talk about your understanding of long-term trends. Populations at the beginning of the 20th century, middle and end of the 20th century, for example.
Yeah. Well, you heard the Wyoming folks. I mean, they're going through it, and the Colorado folks too. They're probably in the best of times for elk. There's evidence that there's probably more elk in Oregon than there was originally. But those things are changing. And the reason I bring up the eruptive sequence is to show that once, you know, we like to equate wildlife management with lots of mature bulls and lots of cows out there, and it doesn't reflect the biology of the situation. These populations at high density just don't have the production, and that's one of the reasons these elk herds. And the same thing happened in the Yellowstone, incidentally, that happened in the Middle Fork that I showed. I mean, that elk herd basically did not respond to those fires. And the reason is these are at K carrying capacity, food-based carrying capacity, and their reproductive rates are slow. And the wheatgrass, their major forage, does not, the changes in it are short-lived, basically. There is a nutrient flush, but the animals may be able to take advantage of it to some extent, but not over a long enough time. So a lot of the short-term issues that deer at lower density may be able to take advantage of because they're below carrying capacities, food base, and whatnot, and their reproductive rates are a little higher. Maybe they can take advantage, but I don't see this happening. And I think this has consequences for elk habitat management. When you can burn 1 million acres out of a 2 million acre area and not see an elk herd respond, why? I think if we're going to put our bucks to use, why, let's do it where the elk herds are most productive, and that's not going to be in these deteriorating habitat situations. But in the end, in the LOCHSA, for instance, in an anadromous fish stream and whatnot, we're not going to see that kind of shrub field again. Those streams are too valuable to see them burn out. And I think there's a lot of other resources that we're paying more attention to these days. The Clearwater National Forest, at the heights of their cutting, they were putting out 170 million board feet. This year they advertised quite proudly that they had met their forest, their timber harvest goals, 25 million. That's a change of 145 million board feet. And what might they be able to do in there? Well, they were probably way over harvesting it at that level, but nevertheless, there's a lot of timber that isn't going to be cleaned. So my feeling, I think Marty made the point too, that forest management is changing, and that's going to have an effect. And I don't think that the major changes that we saw in shrub steppe that were due to the very heavy grazing that we saw in the early 1900s. It's just not going to happen again. And yet, that kind of disturbance produced a heck of a lot of cliff rose and the kaibab and bitterbrush in Idaho, whatnot. So we're going to be seeing changes on these things, and there's going to be. I didn't mention anything about the political strife, but we're going to have some.
Last question, Jim. Hey, thank you for your comments. I talked a lot about wolves, but you didn't say anything about wolves. Can you give us some of your thoughts about how they fit into the picture?
Yeah, thank you, Bill. Up in Idaho, we don't like to use the W word. It causes the politicians to froth up and the hunters and agriculturalists to riot. So what I use is the acronym UMPAC. That's a unmentionable mammal, probably of the order Carnivora. What that does is reduce the frothing to a drool and the rioting to manageable levels. I was at a hearing in Washington, D.C. when they were thinking about reintroducing wolves. This was the House Natural Resources Committee, and I was representing the Wildlife Society, and they had Congressman Don Young from Fairbanks, Alaska come in. And Congressman Young went to the podium. He was profusely introduced, and this guy had been an outfitter before he became a politician and whatnot, and he opened his notes and he said, if you folks reintroduce the W into Yellowstone, they're going to eat up all the elk, and then they're going to descend on Mammoth and Gardner. They'll eat up all your pets and your horses, and then they're going to work on your kids. And he closed his books, and the chairman of the committee, Bruce Vento out of Minnesota, thanked him profusely, and he left. And so it has come to pass. What we now have in Yellowstone is aspens, willows, blue bunch wheatgrass, and wolves. And the elk are gone. There's a change from, I noticed there are still children in Fairbanks, and based on what Fred said yesterday, there's still children in Gardner. And I think there's secondary compounds involved, and they just apparently aren't that palatable.
Let's give Jim a big hand.